Okay, thank you all for coming here. I really appreciate this, despite two great speakers in the other rooms. I suppose you came here to learn how to .NET all the things. My name is Michał Dudak, and first of all, let me just tell you that I know the position I'm in. This is you, this is me, and this is lunch. So I'll try not to make it too long. First of all, a few words about me. I work as a technical advisor in Polish company Future Processing, and I've been working and playing with .NET for about 8 years now. You can find me on the internet. That's my Twitter handle and my personal site. And let's start with a little bit of history. Now, does any one of you know this date? What happened on this date, 13th of February, 2002? No one. So this is the day that .NET Framework 1.0 was released. And I was not into .NET at this time. Well, I wasn't into programming at all. But I think that at least in some areas, a life of a .NET developer was easier because the code sharing story between different platforms just didn't exist because there was only just a single platform, the full .NET framework. But this situation did not hold for a very long time. And suddenly, other frameworks started to appear. So we had the compact framework, the micro framework. Now we have .NET Core, recently released. There was Mono. We can write .NET applications on Xbox. We can write games in Unity. There are also mobile devices supported, both Windows Phone and Android, also iOS, with the help of Xamarin. So there is a lot of platforms to target right now. And actually, I know you probably all use Visual Studio, right? Have you ever noticed how many different types of class libraries can we use in Visual Studio? Let me quickly show you. So let me open a new project and filter it by library. And perhaps zoom in a little bit. If only zooming in work. All right. Yeah, that's better. All right, so what do we have here? There's a class library portable for iOS, Android, and Windows. There's a class library for .NET Core. There's just an ordinary class library for VB, C#, C++. That's fine. There's another portable class library. There's a Silverlight class library, another portable one. There's a specific portable class library for Universal Windows 8.1. There's another for just Universal Windows and just for Windows 8.1. There's another one for Windows Phone. Yet another for Windows, that's C++, that's not interesting. Windows Phone Silverlight 8.1. Universal Windows. And then we have iOS, tvOS, Xamarin Forms, Android, and Windows Phone Silverlight. So it's quite a lot, and if I just want to write something that's available everywhere, then what should I use? Now, these are all the platforms that are currently supported by NuGet. So this is taken directly from NuGet docs. And you can see we can target .NET Framework, .NET Core, which, by the way, is not the .NET Core that was released recently. This is the technology behind Windows 8 and, I believe, Universal Windows. The .NET Core that's been released this year is NetCore App, to make things more interesting. There's Windows, Silverlight, rest in peace, Windows Phone, Universal Windows. So yeah, there's quite a lot. These guys here are called target framework monikers. You would use them when creating a library, and if you want to specify what target this library should run on. We will see one of these later on. Now, our problem is that we would like to write code that should run on many of these platforms, maybe all of these platforms. What if we want to write a library that, I don't know, maybe does some JSON parsing? So, or maybe we have a mobile application with a similar functionality to a web application. So we'd like to get the business logic, or the domain model out of it, and have it separately. So it is shared by these two projects. Now, if for example, we created a Windows Phone library and created this domain logic inside of it, this library will not be able to run on the full framework. So this is a problem. But obviously, we can run shared code right now, and the solution to this is called Portable Class Library. This is a concept introduced like a few years ago, and portable class libraries, or PCLs, work by finding out the common set of APIs between two or more platforms. So if I get, for example, the full framework and Windows Phone, I will get only the subset of APIs that's available in both full framework and phone. Of course, the more platforms I target, the less APIs I have available. And yeah, let's see how this works in practice. By the way, has any one of you created PCLs or worked with PCLs? Some of you, OK. So let me quickly show you how this works. So let's use the same Visual Studio, and here I'll create a portable class library in C# because C# is cool. And here, can you see it well? OK. Here we can select all of the frameworks, all of the targets for this library. So I can say, I want to run this on .NET Framework 4.6, on Windows 8. Hey, I want to run this everywhere, so let's select all of them. And Visual Studio says, nope. I can't apparently write a library that would target all of these platforms. Now, this may be that these platforms do not have anything in common, which I believe is not really true, because types like integers or strings should be available everywhere. But the other thing is that NuGet and Visual Studio tooling must know about the specific combination of platforms that we want to target. So it turns out that we cannot just randomly select targets as we wish. We have to choose a specific set of these targets. So it turns out that the Silverlight is the offender here. Who would have thought, right? And I can create a portable class library for these targets. Now, I've created another one before to save some time. So this is my portable class library, targeting .NET Framework 4.5.1, Windows 8, Windows Phone, and Xamarin. And I can use this library from all the different kinds of projects I have here. So I have a web application, the ASP.NET 4 application, which, by the way, this library is very small, just a single class, with a single method returning hello.NET developers. So in my ASP.NET application, I have a controller action that instantiates this class and runs its method. Similarly, in the Windows 8.1 application, I have a page with a button, then upon clicking, creates a new instance of my greeter class and runs the method on it. And Windows Phone 8 that basically does the same. I also have an Android application, should be somewhere over here, that does mostly the same thing. So instantiates my class from a PCL and does something with its result. Now I can run this. So let's run Windows app. It works as we thought it would. A Windows application will basically be the same. Debug. Hello.NET developers. Windows Phone application may take a little while to start as Android application, so I will not show it right now, but believe me, it works the same. So basically, it was pretty easy. We just created a PCL that will that is used by different platforms. Now, how does Visual Studio and how does the runtime know what platforms does a PCL support? So to show this, let me just quickly create another PCL. Portable class library, OK, with another set of targets. I don't know, .NET 4, why not? So it turns out that there is really no indication of the target platforms inside this project. The only way Visual Studio knows what platforms are supported is by something weird called, let me show you, Target Framework Profile. And it's a number. Each combination of platforms has its unique profile number. So it's not very readable, and we just can't figure out just by looking at this what these profiles stand for. So if I unload this, the other class library that I created before, oh, sorry, not this one. Here you can say another target framework profile. So depending on the set of platforms that we select, we get a different profile. So this means we can't, like I said, randomly select these platforms. We have to select one of the existing profiles. Now, unfortunately, Microsoft does not provide any documentation whatsoever what these profiles mean. But there's a guide called Stephen Cleary that created a website that shows all the profiles with their matching frameworks. So you can see that we have a finite number of profiles, which is not that large. The largest supported profile number is 344, but their total number is not as near as is not as large. We also have some legacy profiles. So, for example, profiles 1, 2, 3, and 4 are not currently supported. But still, it's not a very large number. Basically, all the most common sets of platforms are covered here. Now, PCLs come with a few problems. First of all of them is what I basically described before. You have to know the profiles, and you have to target the profile instead of just random platforms. And also, if there was a new framework available, say I invented a new .NET framework for refrigerators, because why not? I will not be able to easily add this to this list of Visual Studio supported platforms. I will have to let Microsoft know, let Nougat know that, hey, this is the thing. A lot of people use it, and I want this Microsoft framework for refrigerators on the list. So it's not easy to add another framework. And today, there's quite a lot frameworks appearing in the .NET ecosystem. We've got Xamarin, we've got Mono, and I think having a possibility to add new frameworks would be kind of useful. So if we have a problem with one standard, let's create another and call it .NET standard. Apparently, Microsoft is very good at naming things. And, creating something new has never went wrong, right? So yeah, we've got yet another standard. And what is the .NET standard? It's a specification of APIs that are available on a given platform. So what does it mean in human terms? So PCLs work on existing platforms by finding out the common set of APIs that are included in 2 or 3 or more of these platforms. Whereas .NET Standard is a specification that platforms should support, should implement. So if a platform claims to support .NET Standard, it will have the APIs specified in .NET Standard implemented. So if my library targets .NET Standard, I will know that this library will be able to run on each platform that claims to support .NET Standard too. Now, if you saw anything on the internet from Microsoft about .NET Standard, you've probably seen this diagram. And it shows that .NET Standard library is a base of all the frameworks that are currently there. So of .NET Framework, the .NET Core, Xamarin, a few others as well. But I think this diagram is not quite correct. So I created a better version of it. And this is correct. Because the previous one suggests that .NET Standard is a thing, is a library, whereas it's really not. .NET Standard has no executable code. It's not a library. It's just a specification. So each of these frameworks must implement .NET Standard on its own. So it turns out that .NET Framework implements .NET Standard, as does .NET Core, as does Android. So there is no single .NET Standard library, but all the frameworks implemented separately. But it's still the same set of interfaces. What's more, there is no single .NET Standard. We've got versions of it. And currently, there are 7 versions, 1.0 to 1.6. And it's kind of similar to portable class libraries. So the higher the version, the more APIs you have available, but the number of platforms you will be able to run is lower. The same as with PCLs. If you select all of these platforms, you will not be able to run. You will not be able to use a lot of APIs. So it's the same. 1.6 has the most APIs available right now, but it won't run on as many platforms as 1.0. And I'll show you what these platforms are in a second. And to better understand what .NET Standard is, I find the analogy created by David Fowler, one of the members of the ASP.NET team, the easiest to grasp. So let's imagine .NET Standard is an interface. Then different platforms would be classes that implement this interface. So .NET Standard 1.0 specifies some basic types, integer strings, some types from MS Corelib. And .NET Standard 1.1 adds on top the types that .NET Standard 1.0 specifies. So each next version of .NET Standard implement or specifies more APIs than the previous one. There is no removal of APIs as we go forward with versions. So basically, if we target 1.6, it will support all the APIs from 1.5, 1.4, 1.3, 1.2, 1.1, and 1.0. So now going to platforms, let's say .NET Framework 4.6 happened to implement .NET Standard in version 1.3. So if I had a library that was compiled against .NET Standard 1.1, I will easily be able to run it on the full .NET Framework because 1.1 is included in 1.3. I will also be able to run it on Windows Phone 8.1 and also on Windows, and I will not be able to run it on Windows Phone Silverlight because it implements just version 1.0. And my library might have some types that are only in 1.1. So what about platform support? Currently, .NET Core version 1.0 implements the highest version of .NET Standard. So basically, no matter what version of .NET Standard library we have, we will be able to run it on Core. The same goes with the full .NET Framework, with Mono, and Xamarin iOS and Android. UWP implements a slightly lower version of this. And, well, Windows 8, 8.1, Windows Phone, and Windows Phone Silverlight, their API set is much, much lower. But the most important thing is that the .NET Standard and Xamarin work with .NET Standard libraries today, and we can use it. Xamarin recently, or a few months ago, announced that they fully support .NET Standard libraries, so let's just use them. Now, what exactly are the APIs covered in different versions of .NET Standard? Well, their list is definitely too long to be presented here, so let me just show you a documentation. And, well, I won't talk about each one of them, but we can see that in version 1.0, these are versions of .NET Standard, only few APIs are supported. These are the contract versions of assemblies. So, for example, collections are available, immutable collections, sometimes from component model. But there isn't really a lot of APIs supported in 1.0. 1.1 and 1.2 do not add an awful lot of new APIs, and it's just 1.3 that really gets a large number of new libraries and new assemblies from base class library. 1.4, 1.5, 1.6, they do not add a lot, so I think it may be the most sensible to try to target 1.3, unless, of course, you need to support Windows 8 or Windows Phone. All right, so how do I create a standard library? Where there is a little problem because we don't have the best class solution right now in Visual Studio. And Visual Studio just doesn't support creating .NET standard libraries from file new project. So instead, we have to create a portable class library first and then convert it to a .NET standard library. So let me reload these two. So you've got two class libraries, portable class libraries, and I need to go to their properties, and I'll have this beautiful link, target.NET Platform Standard. Now, Platform Standard is an old name of .NET Standard, so whenever you see this, just think .NET Standard. And if we click this, we will get an information that we may not be able to use the same APIs as in the PCL, because PCL profiles and .NET Standard versions do not map directly to each other. There will be some APIs different. But yes, I'm aware. Let's target .NET Standard. And here we have. Based on my selection of my targets, Visual Studio suggested that I target .NET Standard 1.0. And because I had many frameworks, many platforms selected. But I can change this as I see fit. And this was quite easy. So you just go to Properties, you convert. But it's not always this easy. If a class library happens to reference a NuGet package. So let's do this. If the internet connection here works. Yep, let's use newtons of JSON. Of course, I accept. Right, so we have a packages config with newtons of JSON version 901. Correct. Now, if I go to Properties, and I want to target .NET Platform Standard, nope. Apparently, I will not be able to use .NET Platform Standard from a library that uses NuGet packages. Turns out that you have to use NuGet 3.0 to do this, and for some reason, Visual Studio can't do this automatically. So here's how you do this manually. You have to either uninstall all your packages or just delete packages config. Then try to do this again. And then reinstall all the packages. Now, the difference here is that previously we had packages.config, and now we have project.json. You may know project.json from ASP.NET Core applications, where it's a new project file for .NET Core applications. But do not get used to it, because Microsoft decided to abandon it. Apparently, it's hard to port all the MS Build files functionality into a project.json file. So they are moving all the goodness created for project.json into the new, improved, as they say, MS Build project system. So a couple of important things here in project.json. Here we can see the framework section, and here we specify what frameworks do I want to support, do I want to target? What frameworks do I want to compile against? And I can say, well, .NET Standard 1.1, 1.0, whatever. But the nice feature of project.json is that it allows me to target more than one platform at once. So, oops, my keyboard is gone wrong again. So I may want to target .NET 4.6 here as well. And now when I build this, or if I create a NuGet package out of this, this NuGet package will contain assemblies for both .NET Standard and the full .NET Framework. Now in code, I can check if I'm compiling against the full .NET Framework or .NET Standard with if-def compiler directives. So I can have slightly different or completely different code for these platforms. And to show you how to create a NuGet package with such a library, it's the easiest to do this from the command line. So let me quickly open it up. Please. Yep, all right. So I do have .NET CLI installed, so I have the .NET tooling. And first of all, let me restore all the packages that are needed. So .NET restore. Looks like nothing was really required. And then .NET pack will create a NuGet package. So here in the output, we see that we've created a package for both .NET Standard 1.0 and .NET Framework 4.6. So we can see it. Right, let me just quickly find it. In the output, there is a class library 4. And if I open it in the NuGet Package Explorer, I should be able to see that it has its versions for both the full framework and .NET Standard 1.0, exactly how I authored it. So yeah, that's basically the easiest way to create a NuGet package. All right, so now you should know what's this and how it works, more or less. But why do we even have to care about this? If you are targeting a PCL right now, if you're using PCLs right now, and you write some applications for mobile, for web, and so on, and it works for you, and you just don't want to update them, then fine, you don't have to bother. However, some of the popular library authors opted into using .NET Standard. So for example, if you'd like to use the newest version of AutoFac or AutoMapper, they don't have PCL versions. They now only have the .NET Standard versions. So if you want to use them, you have to have a .NET Standard library or the full .NET Framework library, but I don't see them abandoning the full .NET Framework anytime soon. So I think this may be the main reason to switch. OK, so .NET Standard solves some problems. We can now add another platform because as long as it supports any version of .NET Standard, all the libraries that target this version will be able to work. So if I create my .NET Refrigerator framework and claim to support .NET Standard 1.3, I will easily be able to run all the libraries from NuGet that target .NET Standard 1.3. But it introduces some problems because the API area of .NET Standard 1.6, so the version with the highest, with the widest API surface, has been created based on .NET Core 1.0, and .NET Core 1.0 is a slimmer version of .NET Framework. It makes it quite difficult to convert all the full framework libraries to .NET Standard, because some of the types will be missing. So you have to know that there will be some problems. It doesn't solve all the issues we have in the world. It's not a silver bullet. And we just have to live with it. And that would basically be it, or so I thought about a month ago. But then some interesting things happened. So a blog post appeared by Imo Landworth, the program manager for .NET team, announcing .NET Standard 2. So I had to rewrite my slides. And a week ago, on last Saturday, there was another announcement on Twitter, because this one introduced some breaking changes to how all these things work. And the changes introduced in last week introduced another breaking changes, canceling those previous breaking changes. So in fact, there are no breaking changes in 2.0 whatsoever. So I had to rewrite my slides again. So what's .NET Standard 2.0 then? So remember this slide, the problems of .NET Standard, the low API surface area. Well, .NET Standard 2 claims to fix these problems. So the way it's been designed, it's not based on .NET Core anymore. they decided that, hey, if we want to allow people to easily switch from writing the full framework libraries to .NET Standard, we must provide a bigger API. So how can we figure out what APIs to include there? So they took .NET Framework 4.6.1, they took Xamarin, and they tried to figure out what types are in both. And these types, these APIs, are in .NET Standard too. Well, that's not entirely true, because there exist about 40-something APIs that are in .NET Standard but are not supported in 4.6.1. And even though .NET Standard, .NET Framework 4.6.1 claims to support .NET Standard 2.0, it doesn't have these APIs. This is a weird thing. It's explained in more depth in Imo's blog and in the FAQ in the docs. But these types are not very commonly used. They have something to do with cryptography, as far as I remember. So I guess that most of us really don't have to care about these types missing from the .NET Framework 4.6.1. So .NET Standard 2.0 is a strict superset of 1.6. It does not remove any types, and it just adds, and it adds a lot. More than, well, less than 20,000, but about 20,000 APIs were added to 2.0, comparing to 1.6. 1.6 had about 13,000. Here we have 32,000 APIs. And why did they call it 2.0 then, if there are no breaking changes? Well, first of all, there were supposed to be some breaking changes. And so they decided to bump up the major version number. But then when they decided not to make any breaking changes, they decided to just leave it as is. They explained that it's because so many APIs were added that this is such a significant change, so it's worth updating the major version number. So what about platform support? So here's the previous table, and now we've added 2.0. With .NET Core, a next version of .NET Core will support .NET Standard 2.0. It's not the next version, but it's some later version. It'll probably be either 1.2 or 1.3. 4.6.1 supports it, even though these 40-something APIs do not. A next version of Xamarin, of Mono, and UWP will support .NET Standard 2.0, at least that's what Microsoft says. Also, a portability shim, as they call it, will be included that will allow us to reference the full framework assemblies from .NET Standard to libraries. This is because there's a lot of libraries in NuGet that target just the full framework, but do not use the whole API set of the full framework. So to be able to use them from a .NET Standard library, Microsoft decided to create this layer of magic that will basically allow referencing these libraries from a .NET Standard library. Of course, this will not always work. If a full framework library uses some APIs that are not a part of Standard 2, it will fail. But if these libraries happen to use only what's in .NET Standard 2, it should work just fine. So when can we expect this thing to come out? .NET Standard 1.0 to 1.6 is already there, and nothing will change, I think. And 2.0 will be released with the next version of Visual Studio. The release date of Visual Studio is not announced yet. There were some vague announcements during the Ignite conference. They said early next year, so I suppose this will be at Build 2017 conference, because Microsoft likes to announce new things at Build, or release new things at Build. As for .NET Core, 1.1 will be released later this year, but this is not the version that supports Net Standard 2. It's important to remember. To read more or to get more information about .NET Standard, I encourage you to go to the .NET/standard repository on GitHub. Microsoft uploads all the latest bits there, even before they change the docs. So things about .NET Standard 2 are not in the docs yet. There's just 2 or 3 pages in the GitHub repository that mention 2.0, so this is still a fresh thing. And I hope they will not change a lot. A week ago, when I made the latest changes, I even asked Imo if they're going to make some more changes between this Saturday and this Friday, because I've got a talk and I want my slides to be up to date. And he said, well, they do not expect any more breaking changes within this week. So I hope this slides will be up to date for quite some time, but do not be surprised if they introduce any more breaking changes, for example, calling 2.0.17 or something. So should we adopt 1.x? Should we wait for 2.0? If you want to target multiple platforms and the API set in 1.x is enough for you, then fine, go for it. They will work with 2.0 with no problems because there are no breaking changes. If, however, you need to use some APIs that will be introduced in 2.0, well, you just have to wait or target the full framework for now. All right, so if this talk was too boring or you fell asleep, I think it's a good idea to wake up and just look at the summary. So .NET Standard is the new portable class library, improved, as they say. So library authors using it already, and if you want to use these libraries, so should you. .NET Standard 2.0 will be implemented by .NET Framework, Xamarin, UWP, and .NET Core. And if you'd like to know more about this, check out the .NET/standard repository, and be sure to follow Imo Landworth on Twitter, because he really likes to share a lot of information about .NET. And, well, he knows it all because he's the program manager of .NET, so I suppose he has the most up-to-date information. And, well, that would be it. Thank you for your attention.